purpose of this lab is to determine the unknown concentration pH and pOH of 3 different acids through a process called titration. In this lab, unknown concentrations of acids were used. Safety procedures included wearing gloves, aprons, lab goggles, and closed-toed shoes to prevent contact with the substances. Long hair was pulled back. Titration is the slow addition of one solution of a known concentration to another solution of an unknown concentration until the reaction reaches its equivalent point, which is when the two solutions used in the titration are present in chemically equivalent amounts. The end point is the point in a titration where the indicator changes color. Indicators change color at the end of a point in a titration with a base. The indicator in this lab is phenolphthalein. First, 2 clean bureaus were set up. One burette was used for the acid and the other was used for the base. The acid burette was rinsed 3 times with the acid and the base burette was rinsed 3 times with the base. The acid burette was filled to the point above the 0 milliliter calibration mark with the unknown acid concentration. Some of the acid was released from the burette to remove any air bubbles that were present. The volume of the acid in the burette was rounded to the nearest 0.01 milliliter and recorded as the initial volume. Around 12 milliliters of acid was released into the clean Erlenmeyer flask. The initial volume reading was subtracted from the final reading, and this is the exact volume of acid released into the flask. This was recorded to the nearest 0.01 milliliters.
3 drops of the appropriate indicator, phenolphthalein, was added to the flask. The other burette with the standard base solution was filled to a point above the calibration mark. Some base was released from the burette to remove any air bubbles and to lower the volume to the calibrated portion of the burette. The volume of the base was recorded to the nearest 0.01 milliliters as the initial volume. The Erlenmeyer flask was placed under the base burette. Base was released slowly from the burette into the flask while constantly swirling the contents of the flask. The pink color of indicator started fading with the swirling. The titration started nearing the end point when the pink color stayed for a longer period of time. At this point, the base was added drop by drop. The equivalence point was reached when a very light pink color remained after 30 seconds of swirling. The initial volume reading on the burette was subtracted from the final reading. This was the exact volume of the base released into the flask, recorded to the nearest 0.01 milliliters. The volume used was derived from subtracting the initial volume from the final volume reading. The average volume was derived from adding the 3 trials together, then dividing it by 3. The average molarity of base from the bottle was plugged into the molarity equation to get the number of moles used. For the acid, it was 1:1 since the balanced equations had no coefficients. But for H2SO4, it needed to be divided in 2 since acid to base was 1:2. The number of moles used in the acid was then plugged into the molarity equation to get the average molarity of the acid. This was converted to the average concentration of hydronium ions. We took the negative log of that concentration to get the average pH. The average pOH came from subtracting the pH from 14. The average concentration of hydroxide ions was obtained from taking the antilog of the pOH. The average concentration of hydroxide ions was 1.96 times 10 to the negative first, so we took the negative log of that to get the average pOH, and then to get the pH we subtracted the average pOH from 14 to get the average pH for the base. And then to get the average concentration of hydronium ions, we took the antilog of the average pH for the base.
Compared our data to our classmate and there was only minor differences in the numbers. This could be based on personal error when measuring the substances when they were released into the flask. Another personal error could be adding too much base into the flask after it was already stained pink, which changes the measurements of the pH. A random error could be the use of contaminated acids or bases.